The first time to Antarctica, that moment you step out of the airplane onto the ice and you see this wide horizon of nothingness, it's the most amazing thing, and you get a very different relationship and appreciation of nature out there. My name is Tina van der Flierdt, and I'm Head of Department of Earth Science and Engineering at Imperial College London, and I'm also a professor in this department. I'm a trained geologist, so it's a lot about being in the outdoors and looking at rocks in their natural habitat. Then I'm actually a geochemist, so I take the material to the lab and analyze the chemical fingerprint to learn something about Earth's history. So what I really do with studying the rocks is taking that archive our planet Earth has produced, which tells us what environmental conditions looked like in the past when it was 1, 2, or 3 degrees warmer, and transform it now into the future. So we can feed it into computer models which predict what the world will look like going forward 1, 2, or 3 degrees warmer. I always thought I would go and study geography. I grew up on a dairy farm in the middle of nowhere in Germany, so I feel really, really passionate about learning how our planet Earth works, how it functions, how it worked in the past, and what we might do with that to predict our own future. So when we go down to Antarctica, our goal in that really remote location is to get a core of 200 meters of sediment from below the seafloor, which goes back in time and tells us about the stability of the Antarctic ice sheet in the past. Nobody has done this before, so we're trying to do something quite unique, which is drill in the middle of nowhere through 600 meters of ice. Below that is 50 meters of ocean, and then below that is the seafloor. So that's where we want to drill in, and we want to get 200 meters of sediment core to give us that history back in time. The material that comes to the surface there, no human being has ever seen before. So we just pack it up, send it back home, and then most of the research happens in the home laboratories. When we think about how the world now changes with global warming, the question what happens in 50 or 100 years is very relevant for you, for me, for our children. But as Earth scientists, we bring the capability to play the longer game. For big parts of my career, I actually never thought about my gender, which I think is credit to the places I worked at and how they built a very inclusive environment. We didn't have a woman head of department in the Royal School of Mines before. I feel it's a real privilege, so I hold it now, and I really try to do it justice because I didn't reflect a lot on it before. So when we go to Antarctica, there's people from all walks of life in there. There's engineers out there, but we need a cook, we need a medic, a mechanic, an electrician. What unites all of us when we're out there is that we signed up for something we believe in and we want to achieve together. The problems we're trying to solve now in science, they're the big ones left. The easy things have been done. We just need all expertise we can get. You can learn all skills in life, but what you can't learn is to be passionate about something, so it has to come from within.